All right, so today we're going to start reviewing chemistry from the basics. Let's go first over the very important thing in science, scientific notation. So, how do we write a scientific notation? Let's take a number, for example, 2000. It has to be some number, this box, times 10 to some number, this box. And you have to note that this box is a coefficient. Coefficient meaning any number attached to this 10. And this number will be a power. It'll be the exponent. All right, with that in mind, this answer to number 2000 would be 2 times 10 to the third. Mathematically, this just makes sense. If you multiply 10 3 times, it'll be 1,000. 1,000 times 2 will be 2,000. So it's pretty easy. All right. Now that we have sig figs in mind, let's go over our scientific notation, sorry. Let's go over what sig figs are in science. So sig figs, here are some rules for sig figs that you need to know. Number one, all non-zero digits are significant. All right. Number two, here are some rules for zeros. Now, there are some multiple rules for zeros that you need to keep in mind, actually. So part A is that leading zeros are never significant. Part B, captive zeros. Now I'll explain what captive it actually means. Captive are always significant. And part C, lastly, let me move over, are trailing zeros. Now these are significant if there is a decimal point. So what does this all mean? Let's do an example to find out. So let's take the number 25003.00. Well, we know that all non-zero digits are significant. So 1, 2, 3. And rule number two for zeros is that captive zeros are always significant. So what captive means is that it's between some two non-zero numbers. These two zeros right there would be considered captive zeros. So 1, 2, 3, 4, 5. So we have 5 right now. And lastly, trailing zeros, which means any zeros that are just in the last part of the number are significant if there's a decimal point. And well, there's a decimal point right there. So these count as significant. It's 1, 2, 3, 4, 5, 6, 7. So the answer would be 7 significant numbers. Now, there's actually a third rule for significant numbers. If the unit is something I can count, the sig fig is infinite. So let's say like the number of books, let's say you can physically see 2 books on your desk. That would be infinite number of significant. Let's keep that in. All right. So the next thing is let's go over some multiplication and division of sig figs. So multiplication and division rules. So for this, always keep in mind that it's the least significant figures. So what does that mean? Let's take an example to find out what that means. Let's do 1.24 times 3.6. Now, if you put that in your calculator or you do that in your head, you will get 4.464. Now, how do we round this number to the correct number of sig figs? That's the whole point of sig figs, to find what number is appropriate to round to. So in this case, we use multiplication. And what we mean by least significant figures is this 3.6 right here. That has 2. This has 2. This has 3. So we're going to use 2 as the least significant figures. You know that means this number right here will be rounded to 4.5. And that's that. Now the next rule that I want to go over is for adding and subtracting. I'll just write it as the subtraction symbol. So for this, it's the least number of decimal places. Now, what does that mean? Let's do an example to figure out what that means. So let's take 5.82 plus 2.12 plus 1.8. Now, if you do this in your calculator or you do it in your head, you get 9.74, which is going to be equivalent to how many sig figs? Well, this has 2 decimal places, so we're not looking at sig figs here. This number has 2 decimal places, excuse me, and this one has 1. So we're going to take only one number of decimal places. So this would actually round to 9.7. So keep in mind the difference of significant figures and what to do when you're multiplying, dividing, or adding and subtracting in science. Very well. Now let's go over, not really related to scientific notation or sig figs. We're going to move on to a little bit different topic, and this is just kind of something to keep in mind. So to calculate accuracy is, the definition is how close a measurement is to the real value. So real meaning an experimental value, something where compared to what you hypothesized, the experiment value might be a little different. So here it is. Percent error is equal to absolute value of error over the real value times 100, because you need to make this a percentage. And oftentimes people use the 5% rule, where up to 5% is considered accurate. Now, what is the difference between accuracy and now precision? Precision is how close a measurement, sorry about my handwriting, are to one another. So that is the difference. A measurement, precision is how close the measurement is actually close to one another, while accuracy is to the real value. So it is relative to different numbers. Very well.